So far in our rational functions unit, we've looked at the graphs and we've done simplifying and multiplying. So what's next is we're going to do some dividing. And that makes sense because multiplying and dividing are inverse operations of each other. So remember, rational functions means that these are functions that have fractions and the x is in the denominator. So we're going to remind you about how do we divide fractions. Remember that dividing fractions is the same thing as multiplying by the reciprocal. So let me write that out. Dividing fractions is the same as multiplying by the reciprocal. And what is the reciprocal? That's when you flip the fraction around. So something I've learned from other teachers is KFC. That kind of helps you remember this fact about dividing fractions. KFC stands for K is keep the first fraction exactly the way it is. Don't change it. Okay. F is for flip the second one around. And C is change from division. Here I'll say change from division to multiplication. So if I were to do this on the simple fractions here, then I would say, okay, keep the first one the same. So I'm going to keep 5/8 exactly the same. And then I'm going to flip the second one around. So I'm going to put 16 in the numerator and 15 in the denominator. And I'm going to change this division sign right here to be multiplication. Now we're going to do exactly what we did in the last lesson with multiplication. Remember we said we could either multiply across and then reduce, or we could reduce right away. So what I'm noticing is that 5 and 15, 15 is a multiple of 5. So I'm going to rewrite 5 as 5 times 1. Remember how we factored? And then I'm going to rewrite 15 as 5 times 3. And then I also notice that 16 is a multiple of 8. So I'm going to write 8 as 8 times 1. And 16 is going to be 8 times 2. So we go through and cancel the same things that are in the top and the bottom. So I've got 5 and 5, those cancel. 8 and 8, those cancel. The 1s cancel. And all I'm going to be left with is 2 over 3. So this fraction, 5/8 divided by 15 over 16 is equal to 2/3. That would be my final answer if I was just doing plain old fractions. So now we're going to expand that to have variables. All right, so these would be irrational expressions. So I'm going to do my KFC first. Okay, so KFC, keep the first one exactly the same. So 10x to the 4th divided by 3xy squared. And I'm going to flip the second one. So I would have xy to the 4th in the numerator, and then 6x squared y in the denominator. And I'm changing this division sign to be a multiplication sign. Now we're ready to factor and cancel. Okay, so if I'm looking at just the numbers, well, 3 doesn't go into 10, so I don't really want to do anything with 3. Let's see, 6 doesn't really go into 10 either. However, I know that 2 is a factor of both of those. So I'm going to rewrite 10 as 2 times 5. Okay, I'm going to keep 3 the same. And then I also know that 6 is the same thing as 2 times 3. Okay, so I can see that later I'll cancel out those 2's. Okay, now remember we also said in the numerators we can combine all the x's and y's in the numerators, combine all in the denominator if you'd like. And sometimes that's advisable to keep track of everything. So what you might want to do is, let's just, instead of keeping these as 2 separate fractions, let's just, I'm going to go back and just erase this. And I'm going to just put multiplication here. So instead of putting the 2 and times the 3 as a separate fraction, I'm going to put times 2 times 3. Remember, they all get multiplied anyway. So it doesn't matter whether I split them up or whether I put them right next to each other. Okay, so if I look at my numerators now, I've got x to the 4th and x to the 1st, so that's a total of 5 x's in the numerator. And then I have just y to the 4th, so that's going to stay y to the 4th. And now if I look at my denominator, I have x to the 1st and x squared, so that's a total of 3 x's, so that's x to the 3rd. And then I have y squared times y, so that's a total of 3 y's. Okay, so let's do some canceling. I really want to cancel those 2's. That's what I've been waiting for. And then let's see, for our x's, I have 5 x's in the numerator, 3 in the denominator. So I'm going to cancel out 3 of them in top and bottom. So all 3 of them get canceled in the bottom. If I cancel 3 of them in the numerator, I'm only going to have x squared left. So 2 x's left. My y's, I have 4 y's in the numerator, 3 y's in the denominator. So I can cancel out 3 of them. So that would be all 3 in the denominator get canceled. And then all of them except 1 get canceled in the denominator. So this is just going to be y to the 1st power. If you don't like that, I'll just write y. So what do we have left? So in the numerator, I have 5 times x squared times y. And then in the denominator, I have 3 times 3 is 9. And I don't have any more variables. They all got canceled. So here's my final answer. Notice that I don't have any numbers I can reduce, and I don't have any more variables that can cancel. All right, let's do the next one, and we'll try to do this one a little bit more quickly. All right, so first thing, KFC, right? So I have 16x squared y divided by 81xy squared times 54x cubed y cubed divided by 24x squared y. Okay, so what can we break things up into? All right, so I'm looking at 16, 81. None of these are multiples of each other, but if I think about what are the factors of 16 and 24, I know I just said 16 can't go into 24, so I'm not going to split this up into 1 and 16. But if I think of the next highest one, 8 goes into 24, so I'm going to rewrite this as 8 times 2. And remember, we said we're just going to leave it as all one fraction. So 8 times 2 goes in the numerator. And then I'm going to put, for 24, I'm going to put 8 times 3. So again, the reason I chose 8 times 3 for 24 is because 16 was 8 times 2. And I can see that my 8's are going to cancel. All right, 81 and 54. Yeah, obviously 81 is not a multiple of 54. But let's think about factors, numbers that multiply to give me these numbers. These numbers I'm noticing, like this is 9 times 9. And then this 9 goes into 54. This is like 9 times 6. So I think that would be a good factor thing to use. So let's do that. So we'll do 9 times 6. And then down here we'll do 9 times 9. Alrighty, so we've got the numbers done already, so let's look at the variables. X squared, x cubed, that's going to be x to the 5th. So I'm looking at the x's right now. And then x, 1x and x squared, that's x to the 3rd. And then my y's, I have y and y cubed, so that's y to the 4th in the numerator. And then y squared and y, that's y to the 3rd. All right, let's cancel. The 8's cancel, the 9's cancel. And then we have x to the 5th over x to the 3rd, so all 3 of them will cancel down there, 3 of them will cancel up here, but I'll be left with x squared. Down here I'm going to cancel all 3 of them up here. That'll leave me with y to the 1st. So what do I have so far? I have 2 times 6 is 12, x squared y. And then down here I have 3 times 9 is 27, and there are no variables left. Now the only thing I would want to make sure is I'm not done, even though normally we would be done. I am noticing that 12 and 27, even though 27 is not a multiple of 12, I know that there are some factors of 12 that are the same as the factors of 27. So I know that 3 goes into both of those numbers. This is 3 times 4, and then this is 3 times 9. Okay, so I know that I could cancel out those 3's, right? So let's do that. Always reduce. So we had to reduce a little bit more. And then this time we come up with 4x squared y over 9. So do we have any variables left to cancel? No. And then do we have any numbers that can cancel with 4 and 9? No. So we know we are totally done. All right, so what happens if there's more to it than just all multiplication? Well, something like this. So again, I want you to be very mindful. Do I have multiplication or do I have division? I have division, right? So we need to change that to multiplication and multiply by the reciprocal, or KFC. So I'm flipping that second one. Notice that the first one, we kept that the same, and we're flipping the second fraction, and we've already changed the multiplication to, or the division to multiplication. Okay, so that's always the first step when you have a division problem. Next thing, we have to factor, and since we have pluses and minuses, this is where you get out your flow chart, right? So 3 obviously doesn't have any pluses or minuses. I don't have to worry about that. X plus 7, does it have any greatest common factor? No, I can't divide anything by both of those. And it has 2 terms. So is it a difference of 2 squares? No, it's plus. Is it adding 2 cubes? No, this is an x cubed, so we're done with that. There's nothing to factor there. So now let's look at the numerator right here. Do we have any greatest common factor? No. We have 3 terms, so that's when we're going to look for, can I multiply 2 numbers to get equal -7 and add to give me 6? So 2 numbers that multiply to give me 7, well, that's just 7 and 1, isn't it? So I have to do 7 and 1. And would it be, since I want to get -7, I would need 1 to be positive, 1 to be negative. So do I want it to be 7 minus 1 to equal 6, or do I want 1 minus 7 to equal 6? You got it. 7 minus 1. So I want +7 and -1. All right, so now we're factoring the denominators. Now I'm on this guy. So go through the flow chart. Is there a GCF? Yes, there is, isn't there? I can divide each of these by an 8 and by an x. You see that? So I'm going to have 8x in front of my parenthesis, and then inside I'm going to have just 1x minus 1, and then I'm done. What I have left is just 2 terms. It's not a difference of 2 squares. This is an x squared, and it's not x cubed, so I know I'm finished. So now we're at the canceling phase. This is where it says divide out common factors. This really means cancel. Cancel what you can. Remember, you can only cancel things that are multiplied. So what's multiplied? Well, this 3 is multiplied by all of that. This is multiplied together. This x plus 7 is multiplied, see how that's there, multiplied by this, and 8x is multiplied by this parenthesis. So only things that have dots in between them can get canceled. So x minus 1s, you see how those are both the same, those can get canceled. X plus 7s, those can cancel out. And what do I have left? I just have 3 over 8x. So I have 3 over 8x. And remember, always ask yourself, can I reduce 3 over 8? No. I cannot, so I know I'm finished with that one. All right, so let's look at one more example like that. So we've got some addition and subtraction there, but we also have division, so make sure you're doing your KFC first. So I'm going to keep this first one the same. I'm going to flip the second fraction, and then I'm going to change the division to multiplication. Multiplying by the reciprocal. All right, now we're in the factor step. Okay, so this first one, can't factor that. There's no addition or subtraction, so I'm just going to leave it like it is. And this first denominator, I have a subtraction, so go through their flow chart. Is there a GCF? Well, I see something. I can divide them both by 3. So I'm going to put my 3 in front of the parenthesis, and then I'm going to have 2x minus 1 left inside the parenthesis. Notice I only have 2 terms left over, and this is not an x squared or an x cubed, so I don't have to go any further with my factoring. All right, over here, I'm going to work on this numerator now. Can I divide this by anything? You do your GCF. I'm not seeing any numbers, but I see I can divide them both by an x. So I'm going to put x in front of my parenthesis, and that's going to leave me with 2x minus 1. All right, and then again, I have 2 numbers left, 2 terms left, and this is not an x squared or x cubed, so I don't have to go any further with factoring. All right, now we're ready for this denominator. Can I do any GCFs? Yeah, do you see I've got both a number and a variable? I can divide both of these numbers by 3, and I can divide them both by x. So I've got 3x, parentheses. Now what do I get when I'm left over? I get 1x, and then 12 divided by 3 is 4. And then I only have 2 terms left, and it's not x squared or x cubed, so I'm done. So we've done the factoring phase. Now we're ready for the cancel out phase. Okay, so what's being multiplied? I have 9 times x squared times x times 2x minus 1. Here I have 3 times 2x minus 1 times 3x times x minus 4. So what gets to get canceled? Well, I can cancel the 2x minus 1. Do you see these x's in top and bottom? I can cancel those. And you may not see this at first, and that's okay, but I can break up 9 into 3 times 3, but we'll wait for that. So let's just do it all, what we have so far. So we have 9, what's left over in the numerator, 9 times x squared. And then in my denominator, I have 3 times 3, that's 9. And then I still have that parentheses x minus 4, so I'm going to rewrite that. Okay, so this is what I was talking about. You see how the 3 times 3 got combined to be 9, so I can cancel those 9s out. Remember, I can still cancel those because those are multiplied by, this one's multiplied by x squared, this one's multiplied by x minus 4. Okay, so here I have x squared divided by x minus 4. And again, I'm gonna challenge you. Can I cancel out this x and this x? Well, is this x multiplied by the 4? No, it's subtracted, right? This is x minus 4. So I cannot cancel this x. These are combined. They're married together. So the only way I'd be able to cancel this is if there is an x minus 4 in parentheses up in the numerator. Okay, so don't try to cancel those. This is as far as we can go, and I don't like yellow. Sorry, let me go back to red. And that would be my final answer.